Hello everyone. Let's solve some of the linear algebra questions that are asked in the GATE exam in the previous year. So let's start with the question number 1. Question 1 says m to the power 4 will be the identity matrix and m itself is not identity. The square of m will also not the identity and the cube of m will also not the identity matrix. Then for any natural number k, the m inverse equal to what? So they're asking about the inverse of this matrix M, and here the k is the any natural number. So let's first of all write this first condition, which is m to the power 4. It is the identity matrix. So we have to find the inverse of this M matrix. So let's multiply this equation by M inverse both the side. So just simply multiply with M inverse. So we are getting m cube will be equal to the inverse of this matrix. But here if you see the option, then none of the option is given in this term. They are given in the general term, and here they are introduced a number k, which is any natural number. So we have to find the answer also in the terms of k. So you can see here the all the option are in the terms of 4k, 4k, here also 4k, here also 4k. So we have given the condition is that m to the power 4, which is identity matrix. So let's rise this equation with the power k. So simply m to the 4 equal to I. Now let's rise the power of this equation. So uh, m to the 4 raised to k, and we have to also raise the power on the right hand side, but it is just simply again give the identity matrix. So here we get simply m to the 4k equals again the identity matrix. Okay, so now let's multiply m this equation with m to the 4k. So here on the left hand side we have m to the 4k plus 3. On the right hand side we have m to the 4k, and this m inverse remain as it is. Now this m to the 4k, it is just simply nothing but again the identity matrix. So it will again give this m inverse matrix. So we have find out the inverse of the matrix in the general term. So you can compare the option and see option B is the correct answer. Okay, let's move to the question number. Okay, question 2 says the value of x for which the matrix A. Okay, we have given matrix A, which is 3 cross 3, and here x as an unknown. This we have to find the value of x such that at least one of this eigenvalue of this matrix will be 0. So here we don't need to find the characteristic equation by finding the determinant equal to 0 and uh, find the equation in the terms of lambda cube. We just simply use the property of eigenvalues. uh, if the let's suppose lambda 1 and lambda 2 and lambda 3 are the eigenvalue of 3 cross 3 matrix, then the multiplication of these three value will just give the determinant of this matrix A. So here it is given that uh, at least one eigenvalue is an 0, 0 is an eigenvalue of this matrix A. If at least one of the value from these three value will be 0, then determinant also 0. So let's equate the determinant of this matrix A equal to 0. Now let's form the determinant of this matrix. So here 3, 2, 4, 9, 7, 13, minus 6, minus 4, minus 9 plus x, and we have to equate the determinant equal to 0. Now if you look carefully, then you observe if see this element minus 6, Here we have plus 3, here we have minus 4, here we have plus 2. If now if we multiply this first row with minus 2, then here we are getting minus 6, which is same as this one. Here we are getting minus 4, which is again the same as this element, and here we are getting minus 8. And we know that the determinant of this matrix equal to 0, and we also know the determinant of any matrix will be 0, then at least two of its row are linearly dependent. So here we don't need to find the determinant by the expanding of this determinant. We have to just compare this entries of this first row and second row, third row, and we have get the value of x. So first of all, let's multiply this row 1 with minus 2. So what we are getting here, we are getting minus 6, here minus 4, and here we are getting minus 8. This second row will remain as it is, 9, 7, 13. Third row will remain as it is also, minus 4, 6, minus 4, minus 9 plus x. Now this entry exactly same as this one, and this also exactly same as this. If this entry will also minus 8, then the row 1 and row 3 are identical, and we get the determinant equal 0. So let's compare this third element with minus 8. So we can say this third element is minus 8, then and then the determinant of this whole matrix is a 0. So here we can easily find the value of x, which is simply just 1. So that's it. We have find out the value of x, for which the one of the eigenvalue of this matrix will be 0. So here we have to write 1. Okay, let's solve question number 3. Question 3 says we have given a matrix A which is 4 cross 4. This is the 4 cross 4 matrix, and we also have given the determinant of this matrix which is 100, and the trace of this matrix which is 14. And they are asking about the absolute value of A minus B. We have two unknown here, A and B, and they are asking about this absolute value of this A minus B. So first of all, uh, let's write this trace. We know that the trace is just simply the sum of these four diagonal element, A plus 5 plus 2 plus B. So we are getting simply A plus B, 5 plus 2 will be 7, and it is given that the trace of this matrix A is 14. So here we can get value of A plus B, which is simply just 7. Okay, now the another condition is given that the determinant of this matrix will be 100, but here the matrix A is 4 cross 4. So we have to first decompose it into the minor of 3, and then the find determinant of those 3 cross 3 matrix. So here it is, if you look carefully, then it is easier to decompose this matrix with respect to this first column, because here these two entries are 0. So the minors of this are not contributing the determinant of this 4 cross 4 matrix. So let's expand with respect to this first column. You can do about the any rows or column, but here I am doing about this first column. So here, so simply just write this A, and just delete this column which contain this element A and this first row. So we are just simply end up with this 3 cross 3 matrix. So let's write here as it is. Now here this is the first element, so we have positive sign. Now the second element, we have put the negative in the front of this, because remember the sign factor minus 1 raised to I plus j, and I and j is the index of this corresponding element of which are of whose we are finding the minors. So here this element is A11 and this A2 is corresponding to the element A23, the second row and first column. So we are in the second term we are getting minus this 2 remain as it is. Now delete this row, second row and first column, and write the remaining 3 cross 3 matrix as it is. Now we don't need to write the other minors of this 0 and 0 because they are not contributing to the determinant, because here the entries are 0, so we just simply getting 0 from these two entries. So and the determinant equal we have given, which is simply just 100. So let's uh, find the determinant of this 3 cross 3 and this 3. So here you can see this matrix is just an upper triangular matrix, because the all the entries below the diagonals are 0. So we are calling it upper triangle, and we know any triangular matrix have the determinant equal to just the multiplication of this diagonal element. So just simply a remain as it is. Here we have to multiply this 3 number, so we are getting just simply 10b. Now minus, we have to find the determinant of this also. Here we have this column is in 0 0. So we just simply get the determinant equal to 0. Now it is given that the determinant of this matrix equal to 100. So here we can find the value of A and B, sorry, a multiplication of AB, which is just simply the 10. Now we have two equations and two unknowns. We can solve for the A and B, but here they are asking about the A minus B. So we just simply use this equation, A plus B whole square equal to A minus B whole square plus 4AB. If you expand this left hand side and right hand side, you will get the same answer on the right hand side and left hand side. So we already know the value of A plus B. We also know the value of AB, and we have to find the absolute value of A minus B. So let's put all these value. So here 7 square the A minus B square remain as it is first, plus we have AB equal to 10 and we have to multiply it with 4. So it just simply 40. So here we can get A minus B whole square is just simply 49 minus 40. So just simply 9. Let take the square root both the sides. So we are just end up with A minus B equal to plus or minus 3. And now they're asking about the absolute value, so we have to take the mode of this, and in the output we just simply get the positive number, which is 3 here. So we have find out this value of A minus B, which is simply just 3. Okay, let's solve question number 4. Question 4 says if the vector, okay, we have given 3 vectors in terms of e1 e2 and 3 e3, and they are saying these 3 vectors are form an orthogonal basis of the 3-dimensional real spaces R3. Okay, these 3 vectors are the basis of R3. Then the vector u, okay, we have another vector given u, which is belong to also R cube, can be expressed as, okay, if these three vectors are basis, then the any vector from the R3 can be expressed as the linear combination of these 3 vectors. So here we have to find the scalar, some scalar, such that we multiply it with this e1 e2 and e3, then in the output we are getting this u vector. So let's write, we have to find the value of some constant ABC. Let's write here, this is a given matrix U. If we multiply this vector with A, then A E1, okay, here it is vector, let's write the vector sign, plus if we multiply some scalar with this E2, let's assume here it is C, Then in the output we get this u vector. So let's write the u vector which is given as 4, 3, minus 3. Now let's write the right hand side. Here a is the scalar and the vector e1 is given as 1, 0, 2. Here again b is also the scalar. The e2 is given as 0, 1, 0. Here again c and e3 vector which is minus 2, 0 and 1. So let's uh, write here this left hand side will remain as it is 4, 3, minus 3, and the right hand side let's add up these three vectors after multiplying this scalar. So here we are getting a in the first entry, here we are getting simply just 0, and here minus 2c. In the second row we just simply get b from this second and 0 from this first and third, and in the third row we are getting 2a from this a e1 vector, 0 from the e2 and c from the e3. Now these both vectors are equal, then we compare the entries on the right hand side and left hand side. So let's compare this equation with all our known value. So we are getting a minus 2c equal to 4, and we got the value of b direct from this second equation, sorry second row, which is b equal to 3, and here from the third row 2a plus c equal to minus 3. Let's multiply this first equation. Okay, let's multiply this second equation with 2. So we are just simply getting 4a plus 2c equal to minus 6. Let's add this equation with this, sorry not 4a, a minus 2c equal to 4. So let's add up these two equations. So plus 2c minus 2c will cancel out. Here we are getting 5a and here minus 2. So we are getting 5a is equal to minus 2. So simply a will be minus 2 by 5. Now we have find out the value of a and b. We have to find the value of c. So let's simply put the value of a in this equation. So simply 2 into minus 2 by 5 plus c we have to find out equal to minus 3. So here minus 4 by 5 plus c equal to minus 3. So okay, so we are getting minus 15 plus 4 which is minus 11 by 5. Okay, so we have find out the value of c also, which is minus 11 by 5. Now we have find out this all scalar abc. So just simply put the value of a, b and c in this equation and we can find, we can get our answer. So let's compare all option one by one. In the option a we have a is minus 2 by 5. Okay, but here b is minus 3 and we are getting b is plus 3. So option a is the not correct. Here again option c is the not correct. Okay, the remaining two are the option b and d. Now the c is minus 11 by 15. So option d is the also wrong because here it is plus sign. So option b will be the correct answer. Okay, let's move on the question number 5. Question 5 says the consider a 3 cross 3 matrix with every element being equal to 1. Okay, we have given a 3 cross 3 matrix and all the entries of this 3 cross 3 matrix are 1. Then it's only non-zero eigenvalue. Okay, they're asking about the non-zero eigenvalue of this 3 cross 3 matrix. So let's first of all form this matrix. Here we have 1, 1, 1. Okay, all entries are 1 and we have to find the non-zero eigenvalue of this. So first let's form the characteristic equation and find the determinant, and equate is equal to 0. So let's form the determinant. 1 minus lambda 1 1 1. Now find the determinant of this 3 cross 3. Okay, so let's 1 minus lambda into this 1 minus lambda multiplied with this, so 1 minus lambda square, we have minus 1 in the second element, we have multiply with this element with this, so 1 minus lambda minus 1 plus plus in the last element we have 1 minus multiplication of this both, so 1 minus 1 minus lambda, and we have to equate equal to 0. So here let's multiply this term with this both, so here 1 minus lambda cube minus 1 minus lambda, here this plus 1 cancel with this minus 1, so here we are getting simply plus lambda, here again this one cancel with this minus 1, and we are getting again plus lambda equal to, we have 0. So let's do further simplification. 1 minus lambda cube, here minus 1, here again we are getting plus lambda, so we are getting plus 3 lambda, add this 3 equal to 0. Now let's expand this cube term, so here 1 minus lambda cube plus 3 lambda square minus 3 lambda, this 2 and 3 remain as it is, minus 1 and 3 lambda, we have equal to 0. So here this 3 lambda will cancel with this, and this plus 1 cancel with this, sorry, this minus 1 cancel with this plus 1. So at the end we are getting just simply 3 lambda square minus lambda cube equal to 0. Now take the lambda square out, so 3 minus lambda equal to 0. Now we can see either the lambda square equal to 0 or lambda equal to 3. That's it, we have find out the non-zero eigenvalue, non-zero eigenvalue of this matrix, which is just simply 3. So answer of this question is 3. Okay, let's move on the question number 6. Question 6 says a 3 cross 3 matrix P such that, okay, P cube it's give P itself, then the eigenvalue of PR. Okay, here we know from the Cayley-Hamilton theorem that the characteristic equation of the any matrix, it is satisfied by its own matrix. Okay, so we can write here P cube as an lambda cube in the reverse direction from the Cayley-Hamilton theorem. So it is given that cube of this matrix give the matrix again. So we have to put the eigenvalue at the place of this P cube. So we can say that lambda cube equal to lambda from the Cayley-Hamilton theorem. So we have to find this value of lambda. So let's bring this lambda on the left hand side. So lambda cube minus lambda, we have to equate is equal to 0. So let's take lambda common. So lambda square minus 1 equal to 0. Now either lambda equal to 0 or we have lambda square minus 1 will be 0. So we have find out the one value which is as in 0. Now here we are getting lambda square equal to 1. So lambda will be plus or minus 1. So that's it. We have done. They are asking about the eigenvalue of this matrix P, which are just simply 1, minus 1 and 0. So the option D is the correct combination of these three value. So option D is the right option. Okay, let's solve question 7. Question 7 says let the eigenvalue of 2 cross 2 matrix A be 1 and minus 1. Okay, we have given this two value as a lambda eigenvalue. Lambda 1 is 1, and let's assume lambda 2 will be minus 2. with eigenvector. Okay, we have also given the eigenvector x1 and x2 for matrix A, for matrix A, uh, respectively. Okay, and then the eigenvalue and eigenvector of the matrix. Okay, so they're asking about the eigenvalues and eigenvector of this matrix, which is let call it matrix M, which is just a square minus 3a plus 4i. Now, from the property of eigenvalue, uh, if we want to find the eigenvalue of this matrix M, then we just simply put this individual eigenvalue at the place of A and square it or multiply it with 3. We just put the value of this eigenvalue at the place of A, and here the identity matrix has a value of eigenvalue as in 1 1. So we are here, we are just simply getting plus 4. So let's put first of all this lambda 1. So we are getting here uh, 1 square minus 3 into 1 here, plus into eigenvalue of this identity matrix is again 1. So what we are getting, 1 minus 3 plus 4, which is 2. Okay, so we have find out the one of the eigenvalue of this matrix M, which is the in terms of polynomial of this matrix A. So we have to just perform the same operation on this individual eigen values of this A matrix. Now let's do for the lambda 2, which is minus 2. Let's do it here. So here minus 2 square minus 3 into minus 2. Again, this identity matrix have eigenvalue as in 1. So here we are getting 4 plus 6 plus 4. So we just simply getting 8 plus 6, which is 14. Okay, so we have find out these two eigenvalues, which are 2 and 14 for this matrix M. And now we also have to find the eigenvectors of this M matrix. Now remember that the eigenvalues are changing by change, but the eigenvectors will remain as it is. It does not depend on whatever will be the operation on perform on this matrix A, either it is cubed or some in terms of some polynomial, but the eigenvector remain as it is. So eigenvector are still x1 and x2, and the eigenvalue of this new matrix M will be 2 and 14. So option B is the right answer. Remember that the eigenvector are not changed by any operation. Okay, so we just end up with option B. Okay, let's solve question 8. Question 8 says consider 2 cos 2 square matrix A. Okay, we have given in terms of sigma x and omega, and again a sigma. Okay, and where x is unknown. Okay, here this x is an unknown, here x is an unknown, and they're asking if the eigenvalue of the matrix A are uh, omega, sorry, sigma plus j omega and sigma minus j omega, then the value of x equal to what. Okay, so let's okay, we have given the two eigenvalues, so let's use the property, the sum of these two value lambda 1 plus lambda 2 equal to the trace of this matrix A. So let's sum up these two value. We are just simply getting 2 sigma equal to, okay, 2 sigma. Okay, we are getting nothing from this first property. Now use the second property. uh, what was that? Just multiplication of these two value, which is just the determinant of this matrix. So first of all, let's find the determinant, which is sigma square minus omega into x, and we have to multiply with, sorry, on the right hand side we have to multiply with these two value. So omega, sorry, sigma plus j omega into sigma minus j omega. Now just simply you can see it is just simply a plus b into a minus b. So we are getting sigma square minus j omega square. So here sigma square, here j square will be minus 1, so we are getting plus, and the omega square on the left hand side we have omega square minus omega into x. Now we can compare this omega square with this omega square, and this second term which is minus omega x equal to omega square. Now 1 omega will be cancelled out with this omega square, and we are getting minus x is equal to omega, and we have to find the value of x, so which is just simply minus omega. So that's it, we have find out the value of x which is minus omega. So option C is the correct answer. Okay, let's solve question number 9. Question 9 says the solution to the system of equations. Okay, we have given two equation and two unknown x and y, sorry, two variable x and y. We have to find the value of x and y. So let's first of all form the coefficient matrix. 2, 5, minus 4 and 3. Now write the this vector x and y. On the right hand side we have to write 2 minus 30. Okay, so let's form augmented matrix. 2, 5, 2, minus 4, 3, minus 30. Okay, let's reduce this matrix into echelon form such that we can find the value of x and y so easily. So first of all, let's multiply with first row and multiply this first row with 2 and add in this second row. So r2 plus 2r1 gives new r2. So let's perform this operation. First row will remain as it is. Now the second row we are getting minus plus 4 here, plus 4 from this first row, and we already have minus 4, so we just simply getting 0. Here we are getting 10, we have 3 here, so we are getting 13. Here we are getting again here 4, we have minus 30 here, so we get minus 26. Now we have reduced this matrix, so let's compare again this coefficient with this right hand side. So simply 13y equal to minus 26. So we can say y equal to minus 2. Now from the back substitution we can also find the value of x. Now we have find out the value of y. So let's put it here. 5 into minus 2 equal to 2. So here we are getting, here it is minus 2. So we are getting minus 10 equal to 2. So just simply we are getting x is 6. So now the value of x and y respectively 6 and minus 2. So option C is the correct combination of x and y. So that's it, we have done, and thanks for watching.